Hello guys, welcome back to my channel. Mason African Motives, still working on engineering science and 4 level. So in this platform we shall actually be working on kinematics, which is from one of the question papers that we are having here. And we have got this question, guys. As you can see, we've got a total of 12 marks from everything here. As a total of 12 marks. So you just want to see how you're supposed to answer these typical questions there. So the question reads, an aircraft can fly at a velocity of 280 kilometers per hour with no wind interference. Take note, guys. When there is no wind interference, it's actually flying at 280. All right. It must fly to an airport 275 kilometers north, so which means it's going to the north of its current position. Okay, a northwesterly wind with a velocity of 72 kilometers per hour is blowing. So there's a northwesterly wind which is blowing. All right. Calculate the direction in which the aircraft must fly to get to the airport. Okay, guys, this is what is happening here. If you are to cross-check, we've got two things which are happening here. The aircraft was just flying to the north, which means on ideal circumstances, it was just like this. This is to the north. It was just going direct to the north. Okay, with the given with the given velocity, which is 280, like that, just 280 kilometers per hour. All right. Then there is a northwesterly wind which is blowing. So this one is northwesterly. Take note, guys. This is northwesterly, which means north 45 degrees to the west. That's northwest. So remember, this is according to this is your north, this is your west. So the wind is blowing in this direction. Okay, this is where the wind is blowing. This is the wind. And we've got 45 degrees, which is going to be created in between there. All right. So the wind is blowing this direction. So definitely is going to cause an effect to the aeroplane there. But we are worried with what is going to be at the end of this wind. The wind is going to continue like this, okay? So it's going to continue like this, like this. So it will be pointing this way now. So this is where we are going to have it at the end. Remember, whenever from your first diagrams in engineering science N3, we talked about a condition where everything should be taken from the point, this point, not to the point. That is why you have to extend this force so that it will be away from the point like this. So definitely, if this is 45, remember guys, we said 45, 45. So this is 45, this is 45. So definitely this is 45, and this will be 45. But due to the effect of the wind that is caused, it means this is going to shift to the opposite direction of the wind, which is blowing. So this is going to be at the end is going to be adjusted like this. So this is where we are going to have it now. So it will be like this with angle theta and 280, like, so that it affects, because take note guys, if the wind is blown, is being blown, and the resultant of the wind is in this quadrant, therefore the aeroplane is supposed to be in the opposite quadrant. If it was in this quadrant, it was going to be, the aeroplane was going to be in the other quadrant, the aircraft. So that's like how you actually work out this diagram. So at the end, our diagram is going to be like this. At the end, this is what we are going to have, guys. At the end, we're just going to use broken lines here. Okay, so let's just say this is our reference point. And also the north, in the north, there is nothing that is left in the north. So I'm just going to use broken lines again. But we are going to have something like this. It will be shifted a little bit. A little bit, guys. It will be shifted a little bit. So let's just say this is how the aeroplane is shifted from where it was here, so it has shifted to this point now. So this is the speed of the aeroplane, which is 280. Okay, this one is 280 kilometers per hour. So this is the angle that is going to affect from the west going to the north. So this is the angle that is going to affect from the horizontal to the angle. So you just call this angle theta. All right. Then the wind, remember, it was adjusted in an angle of 45 degrees from this direction. It was adjusted. So now it's on this quadrant, but this one is going to divide into two equal parts. Remember, it's 45 degrees. So this is where we are going to have our wind now with 45 degrees here, and this one also will be 45, but remember, we want the angle that is between the horizontal and the resultant of what, of that force, which is so this is the aircraft and this is the wind. And the wind, what do we have for the wind, guys? The wind on 72 kilometers per hour. So this is 72 kilometers per hour. So that is what you're going to have like that. Okay, so having a diagram makes things easier. Why? Because what I want, guys, is to calculate the direction. Take note, guys, calculate the direction. The direction means theta, so you have to calculate this theta here. So which advantage am I going to take? I'm just going to use vertical components or horizontal components. Okay, so in this case, I'm just going to use h components. Using h components, I'm going to formulate an equation there. How am I going to formulate? This is like this. This is the horizontal here, as we can see, and it will be, they're equal actually. So we're just saying h left is equal to h right. I think this one you got it from your N3. So this is to the left. This was the horizontal to the left. It's a 280 cos. Remember, always horizontal carries cos, so it's 280 cos theta, which is the horizontal to the right, which is this one, 72 cos 45. So when you equate them like this, you don't write the sign that it's a negative, this one. No, you just write as it is, because you are saying they are equal. So there's no need for you to write the sign there. So if they are equal, therefore I'm going to formulate an equation, because I want to calculate this theta, which is the direction. So I'm going to be left with cos theta divided by 280. I'm going to have 72 cos 45 degrees over 280 like this. All right. So to find theta, I can actually convert this to a decimal, or I can just use theta is a cos. To remove this cos, you write it shift cos 72 cos 45 degrees over 280 degrees over 208 like that. So this is going to give us from a decimal 79,53523 and so forth. So I'm just going to round off, which is going to be 79. This is 79,5237. So it's going to give us 524 degrees. So this is our theta, but the direction now should be according to the, so you see now the advantage of having the diagram. You will know where are you starting from and going. This is west going to the north. This is your north, so it's west going west to the north. Okay, so this is going to be, therefore we are going to have west 79,524 degrees to the north. So this will be our direction. So take note, guys, that the pilot must aim. So you just maybe conclude that the pilot is going to aim this and that and that. So as we just wanted to result in, so you can just conclude this with a good grammar. Maybe you guys, you are used in much better English and grammar and so forth. Okay, then calculate the time the flight would take. What about the time now? Definitely for me to have the time, I must have the resultant velocity. There's no way, guys, I must have the resultant velocity in this case. All right, so where am I going to have the resultant velocity now? Because, okay, I'm going to come back here. I can actually use this concept, guys, to calculate the resultant velocity. I can actually theta, because this theta I have calculated, I obtained 90 79. This theta is 79,524. 524. Yes, this is 524 like this. Okay. So you can use components, or there are two options. You can actually use this. Let me just put it this way. So I'm going to explain another way on this one. I have explained this way most of the times, if you still remember. So what you're going to do is to actually calculate this angle here. That's 180 minus this angle. We add to 45, which means you're going to have this whole angle. Then you use your cosine because you'll be having this side and this side. So this will be your R here. So you can calculate your R from cosine rule. So this method, I have explained it a lot. So I'm just going to explain another method this time, so that we don't use like this. This is the only way that we have. So you can actually use components. In this case, find the horizontal components and the vertical components. Okay, but in this case, since we want the velocity, which is this one, so you can just use the vertical. Okay, just vertical components in this case. So V resultant, let's just say V resultant, okay, can be taken from the vertical component, because this is where the plane is going up. It was going to the north, so which means definitely the velocities which are going to affect are the ones which are in the vertical. All right, the one is going up, the other one is going down. So the wind is subtracting. The wind you're going to subtract, because the aeroplane is the one that is going up, so it's going to add. So which means you're going to have something like this. For the velocity, this one, the vertical component, is going to be 280 sine this angle here, 280 sine this angle 79,524 degrees minus. All right, this one is in the vertical, but as you can see, it's in the negative region, so it's going to be minus 72 sine 45. So it's minus 72 sine 45 degrees, or to just know this one is for the wind. So it makes sense also that it's for the wind, so therefore it's going to subtract, because it's opposing what we are supposed to have actually. So you just use your calculator properly. You're going to obtain 224,421. Yeah, 224,421. That's 42103. So this zero cannot change, so this is what you're going to be left with, and these are kilometers per hour. So that's our final velocity there, which is the resultant. Then what are we going to use with this resultant velocity? Remember that we are calculating time, so time is displacement over the velocity. We are calculating time, which is displacement over time, over velocity. Displacement over the resultant velocity, sorry. So this displacement is where the plane here is going to cover 275 kilometers to the airport. So it's 275 to the airport over the velocity of 224,421. So this is what you're going to divide. You're going to obtain 1,225,37 and so forth. So this is going to be 1,225, and this is kilometers and kilometers per hour, so which means this is in hours. All right, but the question is the time, so you can just leave your answer like this in hours, or you can convert this, because it's 1,2. Guys, we have to at least write a proper time. How many hours, how many minutes, how many seconds? So this is a complete 1 hour, so you're going to have 1 hour. Then we subtract this. We have removed 1 hour from this one, so you're going to be left with a 0,225. You multiply by 60 to obtain minutes. So if you multiply by 60, you're going to obtain 13,5, which is now in minutes. So it's 13,5, which means we've got 13 minutes, 13 full minutes, but still there's a decimal of 0,5 of 0,5. So you've taken this 13, you're going to be left with 0,5 minutes times 60. So 0,5 times 60, which is going to give us 30. So this will be in seconds. So this will be 30 seconds. So that is the idea, guys. So you just take 1 hour, write in hours. These will be remaining hours. You convert them to minutes. You take full minutes. You convert the remaining decimal to seconds. So that's how you convert, guys. So you'll be having hours, minutes, and seconds. At least it makes sense that you just write a decimal like that. Okay. Bradley kicks a soccer ball at an angle of 32 degrees. The ball has a starting velocity of 23.5 meters per second. Calculate the following: the height that the ball will reach. Which means we are now back to the projectiles again. So this is what you're going to have on this projectile. We worked with this type of a question before, so it's not going to take us much longer here. So we know that it's going to be like this. Okay, then this will be our parabola like that. All right, so we got our height of h there. All right, so this will be our hue, which is the angle that you're given. Hue, it's 23.5 meters. 23.5 meters per second. Actually, that's what you're having. And we're just going to bring down everything. In this case, the angles, everything 32 degrees, which is the angle of projectile, which is 32 degrees. So they've got our hx, which is, actually, let's just write as vx, which is u cos theta. And this is our vy, which is actually u sine theta. That's how it looks like. Okay, something like that. So the question is, calculate the following: the height that the ball will reach. The height. Which height are we talking about? Definitely this one. This is the height. So what am I going to do to find this height? If you are using this height, you are going to take the vertical components, actually, like, because you're referring to something which is in the vertical. You're not working with the horizontal, you're working with a vertical. So this one, you use vertical components. All right, so using vertical components, what are you going to have? We are going to have actually the velocity, guys, because this is our initial velocity of 23.5. So you can have our vy there, which is the velocity. So definitely we can have the velocity there, which is the initial velocity. So the initial velocity is going to be u sine theta, which is this one, 23.5. So it's going to be 23.5 sine theta, which is sine 32 degrees. Okay, why are we calculating this? Let's just write. We are going to obtain something like a 23, not 23, but 12, that's 12,4531, which is going to be 453. This one is not going to change in meters per second. All right, this is your initial velocity, but whenever you're going up, your final velocity, that's going to be 0 at the end. When you go up to the final point, you'll be having a 0 there. And definitely there's something, because you're going up, there's our g, the gravitational acceleration must be there, which is 9.8 meters per square second. And which means having this, as well as this, I can use the formulas to calculate the height, which is represented by s. So this height is actually just put as s. So I just want you to take a closer look at this formula. V squared is equal to u squared. It's actually plus or minus, okay, 2gs. So when it is going up like this, it's going to be a negative. So which means it's going to be negative because we've got plus or minus. So you take the one that is your working. So in this case, we're going to work with this negative. Okay, so this one is out. So you're going to work with this negative. Okay, so you want to calculate this s, which is right. So simply you can make this to be the subject. It's going to be v squared minus u squared. Or we can just avoid this. Okay, let's just avoid work with the negative. Instead, let's take this to this side. Okay, instead, so it's going to be 2gs. If I take this to this side, it's going to be a positive, which is equal to u squared minus v squared. Then I can simply divide by 2g by 2g. So by doing this, I have taken already the negative of g. So this g is not going to use a negative because already I've taken it to the other side. So that will be my s, which is this one. So that is the height is going to be equal to u squared minus v squared over 2g. So there are so many formulas that I'm going to come with so that we can work on them together. So you can actually substitute here, guys. That is our s or the h. So it's going to be this u 12,453 squared minus v, remember final, that's a 0, over 2g, which is 2 times g, which is 9,8. Yeah, making this can be easier. If you transpose the other way, you're going to divide with a negative, but this one, there's no need of you using a negative because already you neutralized it. So this is going to give you a decimal again of 7,91210, which is 2, because that one cannot change. And this is going to be in meters. So this is our height, or s, depending with the way that you're going to write it, but that's what you had, which is in meters there. And another question is the time it will take for the ball to reach the highest point. The highest point. What is the time that it is going to take to reach this highest point? Okay, so the time, guys, according to what we have there, we can simply play around the formulas there for the time. Like for real, we can actually play around. This is 2.22, guys. Let's just play around there. Let's just take this one again. V is equal to u plus or minus gt. So since this one is going up, we are going to take the negative. So v is going to be u minus gt, like this. So you can just make the t the subject. That's going to be gt there, su minus v. Then divide by g. So t is going to be u minus v over g. Oh, let's just see what you're going to have. What is our u? Because we are still having the same information. This is the same information that we are having. So our u is just going to substitute there, which is 12,453 minus 0 over g, which is 9,8, just like that. So remember, v, guys, the final velocity, that's a 0. Or you can use something which has got h, a formula which has got h. You're going to obtain the same thing though, but what are we going to have there for the end? So this is our time. Definitely it's going to be in seconds, which is 1,270714, and this is going to be 1,271. This is going to change, which is in seconds. So this is going to be, guys, yes, our seconds has got a decimal. It's different from hours, where you can convert hours to minutes and minutes to seconds. But seconds, where can we convert these seconds to? There's no way. So we just leave that as a decimal. But if it was a decimal on hours, that's where you can actually convert that decimal on hours to minutes, seconds. But when it is in seconds, just like that, you just leave it like that. Okay, so that's what we had, guys, on kinematics from this question paper. So we shall work on more question papers, more revisions to come from Mason African motifs till we meet again.